Hi, welcome back to the science of COVID-19. In this video, I want to talk about the concept of herd immunity. What is herd immunity? Well, in a nutshell, it's when enough people in a population are immune to a disease that those individuals in the population that are not yet immune are protected from getting infected by all the people around them that are immune. So here's an example. Here is a naive population. Here, naive means that these individuals have not been exposed to the disease in question. So let's say coronavirus. Here is an infected individual. This individual interacts with these 5 people, and some of them become sick in red. Those individuals interact with other individuals, infecting some of them. Meanwhile, this first individual is now yellow, meaning that he or she is immune because they've recovered from the infection. After this happens multiple times down the line, what you have is a large population of people that are infectious, some people who have recovered, and some people like this one person who is susceptible. Now, this susceptible person can prevent himself or herself from becoming infected by social distancing, isolating, and so forth. However, without those precautions, there's a good chance that this person is also going to become infected because he or she is surrounded by all of these infected individuals. On the other hand, with herd immunity, all of these people in yellow are immune, either because they've gotten the infection themselves and then recovered, or because they've been vaccinated. So here is an infected person. She interacts with these 4 individuals. However, it's only transmitted to this person because the 3 people in yellow are already immune. Then this person who's infected interacts with these 5 people. However, none of them become infected because they're already immune. So transmission here is blocked. At the end of the day, you have a lot of people who are immune. Now, these 4 individuals in blue have not become infected. They're still susceptible, but they're protected from becoming infected by this herd of immune individuals around them. In other words, there's nobody around them that's infectious that could get them the infection themselves. How many people, or what percentage of the population needs to be immune for herd immunity to work? Well, this is related to this concept of R0, which I discussed in the previous video on modeling. Just for a quick review, R0 is how many secondary infections result from a primary infection, meaning how many people do I infect after I'm infected before I recover? And as we discussed, this value of R0 is really crucial to knowing whether the epidemic is going to spread or decline. So if R0 is greater than 1, then no matter which way you dice it, the epidemic will spread. Because this means that on average, each person who is infected is going to infect more than one other person before they recover. And so the epidemic has to spread. On the other hand, if R0 equals 1, the epidemic will be stable. And if R0 is less than 1, meaning on average I infect less than 1 person before I myself recover, then the epidemic will die down. So how is this related to herd immunity? Well, the greater the R0, the larger the percentage of the population that needs to be immune for herd immunity to work. So for example, if on average I infect or people infect 2 other people before they themselves are recovered, then about 50% of the population needs to be immune for herd immunity to work. On the other hand, if on average an infected person infects 4 other people before they recover, then the percentage that's needed for herd immunity to occur jumps up to 75%. Now, especially in the early days of the epidemic, there was a lot of talk about, should we just let the epidemic run its course? Sure, there will be some fraction of people that die, but the rest of us will get infected and then recover. And so after some time, there will be herd immunity, and we don't have to worry about the epidemic anymore. Theoretically and biologically, this could work. However, it would require a lot of people to die. So in this chart, what's depicted is how many people would have to die for each of these different countries to achieve a sufficient level of herd immunity. So here, the yellow dot is 0.2% IFR, or infection fatality rate, meaning that 2 out of 1,000 people who are infected will die. In orange, shows you what happens if there is a 0.6% infection fatality rate. So 6 out of 1,000 people will die who are infected. And here is a 1% infection fatality rate. So 10 of every 1,000 people will die. And what this graph shows is that, let's take the United States, for example, with a 0.2% infection fatality rate, you're talking about hundreds of thousands of deaths that have to occur for herd immunity to work, if only 2 out of 1,000 people die. If it turns out that in reality, 10 out of every 1,000 people that are infected die, you're talking about more than 2 million deaths that will have to occur for herd immunity to work. In a place with a larger population, such as China, you're talking in the millions of people that need to die for herd immunity to be achieved. So herd immunity is something that biologically will over time protect those of us who have not yet gotten sick. However, it requires a lot of people to die if there's no vaccine available. You can also achieve herd immunity with the vaccine. If you vaccinate enough individuals, then those individuals that aren't vaccinated, let's say because they have an immune condition and cannot be vaccinated, they will be protected because of the herd of vaccinated people around them. But if you want to let this happen naturally, where immunity occurs through infection and then recovery, then we will have to confront the fact that millions of people potentially around the world would need to die for this to work. Well, this concludes my videos on the science of COVID-19. I hope you enjoyed them, and be on the lookout for other science videos in the future on this channel. Thanks so much. Please leave feedback.